For this part of today's lesson, use your calculator to complete the graphing portion at the top of this page. Make sure your inequality is set to is equal to 0 or y. Graph the inequalities below using the vertex and the intercepts. Determine what type of line each graph will have based on the inequality symbol. So you want to fill in these blanks with dashed or solid lines. Choose a point that is inside the curve. Test that point. If you get a true statement, shade inside the curve. If you get a false statement, shade outside the curve. And then write your solution set. For this second section, you want to solve algebraically. To do that, you first have to get the equation set with 0 on one side. So for this one, we're going to need to subtract the 2 to the other side. So we're going to subtract the 2 from both sides, which leaves us with 0 less than or equal to x squared plus x minus 2. To solve it algebraically, we want to factor this side. So we need factors of 2 that add together to give you a plus 1. So we end up with 0 is less than or equal to x plus 2 times x minus 1. So this gives us our two x-intercepts. Once you know the two x-intercepts, those are your critical points on your number line. So we know at x plus 2 gives us an x-intercept at negative 2. And x minus 1 gives us an intercept at plus 1. So we know that these are our two critical points. And we want to test whether the function is above 0 or below 0 in each range. So we need to test above or below 0 less than negative 2. We need to test above or below 0 between negative 2 and 1. And then we need to test whether it's above or below 0 from greater than or equal to 1. To do this, we simply choose a value in each of those ranges. So if I choose x equal 3, x equal negative 3, then I substitute that in, I get negative 3 squared. This pen doesn't write very well. Minus 3 minus 2. Negative 3 squared is 9. Minus 3 is 6. Minus 2 is 4, which is greater than 0. So it is greater than 0 here. It's positive. So that is not that is part of our solution set because we want to know where it is greater than or equal to 0. Then we test something between negative 2 and 1. So the easiest thing to test here is 0. So we get 0, 0 squared plus 0 minus 2. So that's negative. So it's negative here. So that is not part of our solution set. Then we need to test something greater than 1. So we'll choose 2. 2 squared plus 2 minus 2. Plus 2 minus 2 is 0. 2 squared is 4. So this is greater than 0. So it is positive in that range. So our solution set then will be all the values less than or equal to negative 2. So negative infinity to negative 2, including negative 2. Union with positive 1. It's including that. Positive 1 to infinity. So that's how you'll solve these algebraically. So remember to get 0 on one side, factor it, use those as your critical points. It was less than or equal to, so these are solid circles, which means they're included. And then test each range to determine your solution. Finally, for this last section, make sure your equations are equal to y or 0. Graph and shade one equation at a time. You can use your calculator or just graph them, knowing how to use the x-intercepts and the vertex. Determine the overlap and identify solutions. So for this first one, y is greater than or equal to negative x squared plus 1. I graph y is greater than or equal to negative x squared plus 1 and shade the region. Then I need to graph y greater than or equal to 2x squared. So I type in y greater than or equal to 2x squared. You see that the overlapping region is here minus this part where this one is up. This one is white, is not shaded. This one is, the blue is shaded inside. This one is shaded outside. So the only overlapping region is this blue here, excluding the blue that's in here where the non-shaded area is. So you can pick any two numbers in this area to be a solution. If I just plot 2 points, I could choose 0, 2, or 3 is fine. So that's in the shaded region. I could also choose -1, 4. So I could choose -1, 4. So any dots, any points that you select inside where it's doubly shaded, where both shading occurs, those would be your solutions, and you would list those under your two solutions that you have chosen. Go ahead and finish the rest of this paper for your notes for class today, and then go back to following the directions in OneNote.